In this video, I introduce self-supervised learning via redundancy reduction. Self-supervised learning aims to learn useful representations of input image without relying on human annotations. The main issues in self-supervised learning are the representation collapse, namely trivial solutions. Barlow Twins uses the objective function to avoid collapse by minimizing cross-correlation matrix between the outputs of two identical networks fed with distorted versions of a sample and maximizing feature of each instance. As shown here, this input image, these two distorted images, YA and YB. The embeddings ZA and ZB are generated from a function f theta. And this ZA and ZB are used to generate the cross correlation matrix C. We use the loss function to train this model. Barlow Twins is easily implemented to learn representations of input images. Compared to other methods, Barlow Twins doesn't require large batches or any asymmetric mechanisms like prediction networks, momentum encoders, non-differential operators, or stop gradients. Barlow Twins operates on a joint embedding of distorted images, namely inputs to distorted views for all images of batch X sampled from a dataset. Function f-set takes YA and YB as input to produce batches of embeddings ZA and ZB respectively. The loss function is defined here, which equals two terms. One is the invariance term, one is the redundancy reduction term, where lambda is a balance factor and C is a cross correlation matrix computed between the outputs of two identical networks along the batch dimension, as shown here, where B is the index of samples and Ij are indices of vector dimension of the network's outputs. The first term in the loss function is the invariance term of the objective, which makes embedding invariance to the distortion by making the diagonal elements of a cross-correlation matrix to 1. The second term is a redundancy reduction term that decorates different vector components of embedding by making the off-diagonal elements of the correlation matrix to 0. This decoration reduces the redundancy between output units so that the output units contain non-redundant information about the sample, as shown here. This diagonal element, we make this diagonal elements CI to 1. And this is the off-diagonal elements. We make these elements close to 0. Barlow Twins advances over NCE-based methods because Barlow Twins doesn't require a large number of negative samples and can thus operate on small batches. For more details, please check with these references. Thank you. Bye.